This video will go through the complete process of going from a Fusion 360 CAD model to a finished part that you can hold in your hand using the Tormach xsTECH router. So I'll be going through how you create the toolpath in the Fusion 360 Manufacturing Workspace, how you go from those toolpaths to a NC file, so the G code, and then how you load that G code into the Tormach xsTECH, and then how you set up the machine, like turning it on, like setting the Workoffset, how you install tools, stuff like that. And then going to how you start your program, cycle start. And then also I'll be doing going through how do you do tool change between two operation, which is something that I have not seen other videos cover. And then I'll be going through some debugging too. So I ran into some problem and I showed how I tried to figure out what's the problem and how to fix it in the code. And in this video, I'll be kind of focusing on how to run the machine like conservatively. I remember when I first started, my top concern was that I'm gonna crash the machine because I'm really still really green about the whole process, and then I'm not sure when I press cycle start how the machine is gonna move, and then there wasn't like I just always felt unsure, and then so I hope that this video will help make that easier. This video is quite long because I want the video to cover the entire process, and this is something that I wanted to have when I started, but I couldn't find. But it's likely that you already know some or most of the stuff that's covered in this video, so do skip around, and everything is timestamped, so I hope it will be easy for you to navigate this video. This is the part that we're gonna make. It's meant to look like the surface of water when some droplet drops onto it, so I have this wavy pattern. And I basically designed this as a demo piece, and it's good because you kind of need two tools, milling tools to make this shape. Going through the design very quickly. So I'm in the design workspace of Fusion 360. So the first thing I did was to draw a half of the cross section of the part that I'm going to make. So just this wavy pattern, and then I revolve it around to get the solid. Then I drew a sketch of the outer square of the part, extrude that, and then lastly I created a chamfer on the edge here. And there's another sketch here that will be used later for the manufacturing workspace, where I use this sketch to confine the toolpath, but more details on this later. And so in Fusion 360, once you're done with the design in the design workspace, and you want to make it with a CNC or other processes, then you go to the manufacturing workspace on the top left corner here and click manufacture. So here is the manufacturing workspace. Make sure you are in the milling tab and not the other ones. On the left here, you can still see, for example, in the model folder here, you can still see the model you're trying to create, and you can still see the individual sketches that you made in the design workspace. And this is useful sometimes because, for example, if I want to confine some toolpath within some geometry, then I can either select it on the model itself, or sometimes I can select the sketch itself, which would be easier sometimes. So I'll hide the sketch. Okay, so before we start, we have to import the tool libraries of the xsTECH and also the machine definition. So the tool library and machine definition can be downloaded from this link, which will be in the description. So this is the link where we can find the tool library and the machine definition. It's kind of hidden in this weird Q&A section. I don't know why Tormach makes it difficult to find this. So download this to folder, this to file. And once you download, go back to Fusion. And in Fusion, first we'll import the tool library. So go to tool library. So once the page finished loading, you see something like this. Yours will probably look different because it depends on what you have open and what you used before. And so go to on the left, go to local and right click on local, and then press import libraries. And then this window will pop out, and just go find your tool library folder. So in my case, the tool libraries is in my download folder, and just press this and click open. But I've already imported it before, so I'm not gonna press open here. And once you're done, you should see this tool library under the local folder, which is the xsTECH Fusion tool library, and it will include the definition of the tools for all the tools that came with the xsTECH. And then now you close this window. Next, we'll import the machine definition. So go to the machine library. So in the machine library, go to again local, and then press import, and then again go find your machine library. So it'll be, in my case, it's in the download folder, and it's the .machine file. And then again press open, and again I already had it imported, so I'm not going to press open here. So once it's imported, then you should see under the local folder the Tormach xsTECH CNC router here. Okay, and then press close. Now that we have imported the tool library and the machine definition, we'll start working on the toolpath. The first thing I would do is to create a setup. Go to the top left corner and press the setup button. And then the first thing to do is to select your machine. So go to select, and then go find where you imported the xsTECH router machine definition. So in local, press this and then click select. And next thing is make sure your operation is milling, and then there's a few more things here, but we'll first go to the stock tab. So the stock tab, you are telling Fusion 360 what's the size of your stock. So by default, it's in the relative size mode, and then it's adding a bit of extra stock. So this, if you see the yellow highlights, it's what the stock looks like in Fusion 360. So in this case, by default, it added a 1 millimeter of extra stock on the side and 1 millimeter on the top. But for our case, actually, we just want to mill out the cavity here, and we're not actually going to make the outside profile here. So in this case, I can just do relative size box, but the offsets will be 0. And make sure you define the stock accurately. For example, like if you want to mill out the outside profile, then you want to actually make sure the stock definition is correct. Otherwise, the machine might try to move really quickly at some places where it thinks there's no stock. But in reality, if there's actually stock over there, then it's going to be a lot of load on the tool, and you might break the tool. And going back to the setup, so now our stock, you can see, is completely aligned. It's almost exactly the same size as our part. And then go back to the setup tab. Next, we have to define the work corner system. The first thing is the orientation. So for the xsTECH, the vertical axis is the Z, and then the left and right axis the X, and then the forward and backward axis is the Y. So in our case, we actually do want to clamp the piece in this orientation, and so by default, this one is correct. But for example, for some reason, if we want to make our part like this, so if we want to clamp the piece vertically on the table, for example, to drill some holes on the side here, then what you actually do is to redefine this orientation. By default, it's following the same orientation as your model. So in your design workspace, you have this XYZ here, so it's following that. But you can actually do whatever you want. So for example, if I want to mount the piece vertically sideways like this, then I can choose this option, select the plane and then x-axis, and I will first thing you choose is your z-axis, and then your x. For example, if I want my x to be the left and right from this orientation, and I press here, and I can flip it, and then I've redefined the orientation of my work on the system. So, but in my case, I just want to keep it as the original orientation, the same orientation as the model. Next, we have to choose where the origin of the work harness system is, and by default, it put this the origin at the center of the top of the stock, and this will work fine for us. But in other application, you might want to put it elsewhere or in some predefined point that you have designed, put in the design workspace. So there's a lot of flexibility in this. So, but then in our case, I want it here. And next is model, basically telling the Fusion 360 which part are you actually trying to machine out. For example, if you have a component with multiple bodies, but you only want to mill out one body, then in this here, you would choose this body. But since I only have one body, then I'm fine with this. And so I can press OK now. So now at the toolbar, there's a bunch of operation that I can do to cut away material from the stock. So the first thing I want to do is actually just use a flat bottom end mill to clear most of these material in this cavity away. And I will use a pocket clearing toolpath. I could also use others, but pocket clearing will work fine here. So first thing you do is to select the tools. So click select. Then go to your local folder and then choose the tool library that we imported. So in this case, I'm gonna choose this tool, which is just a simple flat ML with product ID 39163, and then click select. So once you have selected your tool, then there are many options, settings that you can play with for this operation. And for the first tab, you have your tool that we just selected, and that there's the feed and speed. So feed is roughly basically how fast your tool is moving left and right, forward, backwards, stuff like that. And then speed is roughly speaking, like basically how fast the tool is rotating. And so the default are okay, and then usually for like 1000 millimeter per minute is a good starting point for most material. And for this material, I know I can go a bit faster, so I'm gonna do a 1500 millimeter per minute. And then the geometry, I'm just gonna leave it as default. And height, I'm gonna leave it as default. And pass, the important thing here is the maximum roughing step down. So basically how deep your tool is gonna go into the material. And so 1 millimeter, I'm just gonna leave it as default because 1 millimeter will be fine. And stock to leave, just leave as default. Basically, it's gonna leave a bit of material at the stock for you to clean up later, because right now we're just roughing the shape out, so we don't want to go to the exact size yet. And linking, again, we're gonna leave as default. And then I'm gonna press OK. And now it will be calculating the toolpath. So here is the toolpath. You can see the green, the blue and red line, and then you can see the tool moving. And if you highlight your operation and then press simulate, and then you can actually see the toolpath, and you can increase the speed of the simulation by holding here. Remember that the speed that this tool is moving is not real time, so you can't really judge whether a tool path is too quick or too slow based on this animation. It's just basically showing you where the tool will go. And so you just go through this and see if it's okay. And usually my strategy is that when especially at first, like when you have so many settings, it's often quite intimidating because you don't know whether you're going to do something wrong. But I find that like just press OK first and then look at the simulation, and if the simulation looks okay, then usually it wouldn't be too bad. Like especially in material like wood, then you have a lot of margin for errors. So if the toolpath looks okay, meaning by okay it's not suddenly making some really deep cuts, or the tool is simply at the wrong place, then it'll be okay. So simulation looks good, then I can go back by pressing close. So the next thing I want to do is to clean up this wall here. So after the first operation, I actually left some material on the side here, and I want to clean that up. So for this operation, I'm going to use the 2D contour toolpath. So go to 2D and then press 2D contour, or you can just press here directly. And first select the tool. By default, it's just going to use your previous tool. So, and then in this case, I do want to use the previous tool, so I don't have to reselect it. And for feet and speed, it's also going to inherit your settings from before. For example, the cutting feet rate is 1500 that we set later, just now. But for this case, because I'm trying to use the tool and just clean up this whole face in one pass. So actually, like a lot of the tool is engaged with the workpiece. So I want to go a bit slower for this pass. So I'm going to change this back to 1000 millimeter per minute, the feed rate. The rest, and then the geometry. So basically defining which the 2D contour that I'm going. So I'm pressing the bottom of this face. And so you can see the arrow here. So the arrow right now is inside the contour. So meaning it's cutting the inside, the tool will be inside this contour, which is what we want. Sometimes this might be wrong. By default, you can just press on the arrow and it'll mill on the outside. But the default was correct. So I'm going to leave it as it is. The other stuff I can leave as default. Height I can leave as default. And then passes. You can just leave as default, press OK, and then simulate and see whether it looks okay. So you can see this toolpath is very simple. It's just it just go through it one pass, and then on this stock you can see the green is basically your stock, and then if you see some gray, it's basically you're seeing your model, and then when you see this kind of pattern, is showing that your stock is already, at least at this face, is matching with the model itself. If we go to simulate, and if we slow it down, you can see it going down and then just going for one pass. So again, like if I'm not very confident with my settings, I can just go to simulate and just like carefully look at this whole pass, and I can see that the whole time it's not like cutting some ridiculous slot or having a lot of engagement. And then I feel confident that this will be okay. Okay, and then we can close this. So now with the flat end mill, we have roughed out most of the material. and we'll now use a ball and mill to smooth out these surfaces so that it actually looks like our design. And so we'll do for smoothing out this this geometry, we'll use the spiral toolpath. And then we want to use the ball and mill, so we have to select a new tool. So we select. Again, go to your xsTECH Fusion tool library under local. And you can go find your ball and mill. And I think there's an error with this Fusion library, so make sure you find this tool, which is number 39166. And then I think the Fusion library itself, like it's not listed as a ball and mill. So so if you click ball and mill here, then it this wouldn't show up. This is only showing up. So this 4mm ball and mill is only showing up because I changed it. So what you have to do is what you have to do is probably like right click and then edit tool, and then at the cutter change the type from whatever it was. Probably the flat end mill. Make sure you change it to the ball end mill, which I've already done here. So once you're done with that, again, it's tool 39166, and then choose select. And then with these Toolpath that's under the 3D section, oftentimes you can just press OK first and see, look at the Toolpath, and you'll know what setting you have to tweak. So I'll press OK and wait for the Toolpath to generate. So this is the Toolpath that Fusion generated, and if we look from the side, we can see that the passes are quite far away from each other. So actually, like, the surfaces is still not as smooth as we would like. So we know we have to adjust the step over. So we'll go back into Spiral Toolpath to edit. And we go over to the passes tab. The current step over is 2mm, and I've done this so I know that actually 0.5 will work well. And also I want to change the speed because it's just a ball and mill and most of the material is already roughed out, so we can actually go faster. And so I'll do the cutting feed rate to 1500 millimeters per minute and press OK. So the one thing I noticed is that it's doing many of these passes on the outside that is not actually cutting away any material. So we'll go back in and edit and press edit. And then under geometry, for machining boundary, we're gonna change from silhouette to selection. And at the selection, we're gonna, because we want to confine the toolpath within this cavity, so I'm just gonna select the most outer edge of this cavity, and the rest I can leave it by default. I leave it as the default. So now the toolpath is almost really good, so I can go into the simulation and have a look. And so in the simulation, it's running through this. So after the simulation has completed, we can see that most of the surfaces are quite smooth, except for the center where that tip of the water is. And at that part, the step over lines are quite obvious. Mainly because probably the spiral toolpath is stepping over horizontally, So where at this section where you have a steep angle, then the step over line becomes more obvious. To solve this problem, we'll do the surfacing with two operations. The first operation will just surface the center where the water is where the part is quite steep, and the second operation will surface the rest of the cavity. So the sketch I showed earlier is for this purpose. So sketch 5 in this case, it's just a circle that's in the center of the part that's not even defined. But what it does is that it creates it represents a boundary of the steep section of the part. And we'll use this circle to confine our sketch. So confine our toolpath. So back at our toolpath, at the machining boundary, we'll select that sketch. And now the toolpath will be confined between the two circles. So now the toolpath have generated, and we can see that the toolpath is surfacing everything except for the center steep section. So the center will keep the staircase pattern for the next operation. Then we'll create the next spiral toolpath. We're going to use the same ball and mill as the previous operation. And for speed, it's going to be 1500 as before. Then we'll go to the geometry tab, and then for machining boundary, we are going to choose selection, and then we'll choose that sketch for that circle in the sketch that we define in the design workspace, and that will constrain the toolpath within that circle. And then the step over, we have to reduce it to smaller than before. So before it was 0.5, and now it's going to be, we're going to change it to 0.2, and then we'll press OK. And we can see that this new toolpath only machines the center area with a steeper step over line. And from the simulation, we can see that it creates a smooth surface even at this steep section. Here I'm switching the order between the two spiral operation by dragging. And because the spiral operation by default will machine from inside out, and changing the order like this will make the toolpath smoother, although it's not really necessary. If we look at the name of each operation, at the start there's a T1 for each of the operation. That represents that Fusion thinks that each of these operations is using tool number 1, but we know that we're using two different tools. So the first tool is a flat bottom Endmill, and the second, and then the third and fourth operation uses a ball Endmill. So to solve this, we'll go into the tool library, go to the setup that we were working on. So in this case, it is the demo model v3 setup 2. And then here we can see that our tool is both has number 1. So what you do is just select both two by holding Control, pressing 1 and hold Control, and then press the other one. And then click this button, renumber 2. By default, it will just change the first tool that you added to tool number 1, and the second tool you added to tool number 2. And so the default will just be correct, and you just have to click renumber and click OK. And now you can see that the first two operation uses 2.1, so it says T1, and then the second two operations uses 2.2 with the number T2. Now just regenerate the third and fourth toolpath. And lastly, we need to post the toolpath, which will generate a file that the Tormach xsTECH can read. So make sure you have selected the setup and then click post process. And under post configuration, by default, it should be the Tormach PathPilot / Tormach. This is selected by default because we have select our machine definition to be the xsTECH router. And then choose a place where you save your NC file, then click post. And save it to a USB. For this demo, I'm just going to save it to my desktop first. And then it will Visual Studio Code will show up by default, which will show your G code. And here's a tip from NYC CNC. Just check that in the first few lines that you can see your T1 and T2, which shows that in this code it's using both the 2.1 and 2.2. And just a way to check that you have posted all the operation and not just accidentally just posted one. Now you can just close this and then eject your USB and then plug it into the xsTECH router. First, I assume you have everything hooked up, the machine, the controller, keyboard and stuff. And the first thing to do is to power on. There's a switch at the back here. And then the controller the screen will turn on. And you just have to wait for it to get ready. Now that the boot up has complete, then we'll first reset the machine. We have to first make sure that the E-stop is not pressed. So undo the E-stop by twisting it so that's in the up position, and then you can press reset. So once you press reset, make sure that there's nothing on the table, because we're gonna reference the 3-axis. And when we reference the 3-axis, it's gonna move. So if you have stuff mounted, it might hit it. So make sure it's empty. So and then click reference all 3. And then the machine is gonna move itself into the limit switches, so the machine know its own coordinate system. And once you have referenced, all 3 of these lights should turn green on the ref X, ref Y, ref Z button. To move the spindle of the machine, we can use the shuttle. There are the X, Y, Z button, which help us select which axis we want to move. For example, if I press X, then I'll be moving the X axis of the machine, which is in this direction. So I can move by turning this dial, and clockwise is positive as labeled here, and for X the positive is in this direction. And then I can move other axes. For example, if I move the Y axis, I'll press Y, and then I can again turn this dial, and I can move the Y axis. And the Z axis is the spindle will come down. So here you can see the spindle come down. Besides using this, you can also use this hand wheel to turn a specific step. To determine the size of that step, you go to the screen and you choose this step. So right now, it's the 0.01 is highlighted. That means every click here is it will move the axis by 0.01, and I can increase the step size by, for example, if I increase it to 2, and then I change the axis to X, then every click here is gonna move the machine by 2 millimeters. Next, we'll install the stand for the electronic tool setter, or the ETS. This will be used later to set tool length. I'll move the table to a comfortable position so I can put it onto the table. Install it roughly in this position and make sure the spindle can actually reach the center of this point, because I think the spindle cannot reach the end of the table. So I'm gonna just check that. So yeah, so I can confirm that the spindle can indeed move over here. Now I'll plug in the electronic tool setter. Verify that the ETS actually works by pressing the button, and make sure that this red LED will turn off when you press it. Now we go back to the controller and go to the Probe ETS tab. And then up here, go to ETS setup. So the first thing we do is we have to reference the spindle nose. And so just basically read this and follow the instructions. We have to move the edge of the spindle nose up to the electronic tool setter. So now using the jog shuttle, I'll move the spindle nose, the edge of the spindle nose up to the electronic tool setter where the button is. So just get the edge of the spindle nose roughly above the button. And now we'll press ETS spindle reference. First we have to make sure we change the tool number to 0. Okay, now the tool number is 0, and then we have our spindle nose above the electronic tool setter. Then we can press the ETS spindle reference. So if I press the button now, by doing this, we let the machine know where is the Z position of the ETS relative to the machine coordinate, which is important later when we also use the ETS to set the tool length. Next, we'll install the tool. The tool will be installed into the Collet. So we're going to be using a 4mm tool. So we're going to use a 4mm Collet. First you have to put the collet into the collet nut. To do this, you just put it in sideways and then snap it in by pressing down on your finger with your fingers. And you'll hear it snapping into place. Once the collet is installed into the collet nut, we will put it into the spindle. First I'll move the spindle to a position that I can work with easily. I'll bring the spindle down, and then now I will screw in the collet with the collet nut. So just put it in and give it a few turns. Turn it until the spindle turns with it, and then just turn back out a bit, and then we can install the tool. To install the tool, I'll just grab the tool on the shank on the bottom, and then and then we'll put it into the collet. Just find the center hole and then just push it in. To determine how deep to push the tool in, I like to put it deep enough so that the entire collet is grabbing onto the shank of the tool. I'm not sure if that's 100% necessary. I think it's necessary, but I'm not sure. But that's what I do. And then you don't want to put it in so deep that it starts grabbing onto the flute. So take it out a bit more. And then also you have to make sure that the tool sticks out enough such that it's deep enough to do the operation that you're doing. For example, if I'm cutting a pocket that is 20 millimeter deep, and then my tool is only sticking out by about 13 millimeter, then it's obviously not going to work, because your your collet is gonna hit your work before it actually cut the material. But for this example, I know that the cavity's deepest position is only around 8 millimeter, so so this will actually work. But I'm just gonna take it out a bit more, like maybe roughly like this when I install it. So once I'm happy with how deep I put in the tool, then I'll take the two wrench that came with the machine. There's a big wrench and a small wrench. The big wrench goes to the collet nut, and the small wrench goes to the spindle. So first sometimes you can tighten it by hand a bit first, so then things won't move around. And then I'll put the smaller nut onto the two flat here at the collet, and the big wrench onto the collet nut, and tighten it. And this is kind of by feel, but you'll feel that as you tighten, there will be a sudden point when the torque you need to turn it will increase suddenly, and you kind of go to that and you stop. Yep. It's just kind of by feel. It's hard to describe in video. Next, I will do this section of the controller, which is the ETS G37 position setup. Basically, I have to tell the controller every time I want to set a tool length, where should the spindle move to. And then once it moves to that G37 position, then it's going to come down and touch the electronic tool setter. So first thing, I have to move the tool such that it is right above the ETS. So now that I've aligned the tool right above the ETS, the button, then I can go back to the controller, and then actually you have to move the tool down such that you can see whether it's aligned to the button. But after you're done, move the spindle back up to the highest Z position. So do that. Just move it all the way back up as high as it goes, and then go to this page and click set G37 ETS position. Basically telling the machine, okay, right now the spindle is there, and every time you have to set a tool length, go to this position first, and then go down. And then I'll click this button, set G37 ETS position, and it's gonna warn me because I did this before, but click OK. And now it has a new set of this ETS position. Now I'll set the tool length of the first tool. First, I change this T, the tool number, change it to 1. It's 1 because I know the tool that I just installed is tool number 1, and the number is determined in Fusion 360. Each operation there's a tool number, and I know that for my first operation it's 2-1, so I set it to 2-1, and then now I go to the offset, and you can see that tool 1 is highlighted, and now I can press move and set tool length. So once I press this button, it's gonna move to the ETS position that we set just now, and then it's gonna go down. So I'll focus on here, and the tool is still at the ETS position just now, so I'm gonna move it away just to show that it will be able to move to that position. So now I'll press this move and set tool length. So once I press, it's gonna move back to that position and coming down slowly. And now the machine knows the length of tool 1. Now we can secure the stock to the table. This is the raw material that I'm gonna use. The dimension is roughly 75 millimeter times 90 millimeter, and our cavity's diameter is only around 60, so there are plenty of space for us to clamp onto the side, and there are also enough thickness so that we won't cut into the table when we clamp onto the table. And now use the clamps that came with the machine, and the clamp you put the screw through this big piece, through this thinner piece, and then a washer, and then the wing nut, and then you can slide this hex head into the T slot here from the side. So once it's in, then you can adjust the position of this guy to the appropriate one. And so for this case, the middle one will work well. So just grab onto it, and you just grab on a bit. You don't have to grab on a lot, just a slight bit will be enough. And then tighten the nut, and you can kind of wiggle the screw, make sure the screw is pointing straight down. Now do the same thing for the other side. When you're clamping, again, think about the tool path. You don't want to clamp so much that your tool is gonna hit your clamp. And so in this example, I know that round cavity that I'm making is 60 millimeter in diameter. So I know 0.6. So I know there's enough space in here, and when the operation's running, it's not gonna hit the clamp. Now that the stock is secure and the tool is installed, we have to set our work offset, basically telling the machine where this stock is. So if you remember in Fusion, we set the origin of our toolpath to be the center of our stock. And so basically what we want to do is move the tool tip to this origin that we have set in Fusion 360. Once we move it there, and then we tell the PathPilot software saying, okay, the current position is the origin. And so to help with getting there, I'll first draw a center mark in the middle, just roughly using a ruler. That probably could have been easier if I did that before I installed the stock. And now I'll move the tool such that I can just eyeball it, because I know I have enough margin between the clamp and the actual toolpath, so I can just eyeball this. So I'll move the X and Y and Z to almost be touching the cross. So now I have moved the tool tip. For the X and Y position, I've already moved to the origin that I've defined in Fusion 360, and then for the Z height, I'm still kind of off from the surface. So now I'm gonna move down slowly until the tool just touches the workpiece, and for best practice, you actually want to spin the spindle while doing that, because if this is not wood and this is some harder material, then when you're just pressing it down without spinning the tool, then it could be bad for the tool and the spindle. But I know this wood is soft, so I think that will be okay. So I'm just gonna move down slowly until I see that tool tip just touches the workpiece. Okay, so now I moved the spindle down. So now the spindle, the tooltip is basically exactly at the origin that I've defined in Fusion 360. Now I have to tell the controller that this is the origin, like the current position is the origin. So if we turn to the PathPilot, first make sure that you are in G54. And so in our program, we also define it to be G54. So G54 is the work offset. Basically, it's one set of corner system, and usually everything will be default to G54. But just check that it is G54. If it is not, go here to here and type G54, and then press enter. Okay, and then also make sure, because right now we are setting the origin with two. Hold on, we're setting the origin with 2.1. So the 2.1 is the first tool that we installed. We have to make sure that when we zero out the corner system, we are at 2.1, because the controller will take into account the tool length that we have set just now. So it's very important to make sure that it's 2.1 here. And so now I know that my tool is at the origin that I defined in Fusion 360. And here is, right now the numbers are just random, so I'm just gonna zero them out. So 0, 0, and 0. So basically what I've done is I tell PathPilot that right now the current position is the origin, is the 0, 0, 0 position. And you might see some decimal point, 9, 3, 10. Don't worry about that. I think that's just the resolution of the machine itself. And so now that I've set this, I can move the tool back up a bit. Okay. And now I will load the program. So I've posted the code into this USB. Now I can unplug it, and I'll plug it into the controller. Once the USB is plugged in, go to your screen and then go to the Files tab. So you probably at Main just now, and then go to File tab, and then on the left side is the file system of the controller itself. On the right side, it's usually a USB. So you have to press here press USB, and then you might have to plug in again. Once you plug in your USB, if it's blank, try to unplug your USB and plug it in again. And sometimes like you just have to use a different USB. Like I've tried many USB that doesn't work, but okay, in this case I have it here. And then go find the G code, the NC file that you have posted onto the USB just now. So I know it's in this folder, and then select that folder that you have posted, and then now click copy. Once you copied, go find it in the file system of the controller, and so I find it here. And then now once you have selected that code, press load G code. Okay, and then now it will go to the main screen, and they will automatically show the toolpath here on the screen here. And then with your mouse or with the touchscreen, you can move this around and see if this is correct. So this toolpath looks like what we have just designed. Usually I like to set the work offset first before loading the G code, because if you didn't set your work offset first, then your corner system might be at some random places, and then when you load your G code, it could give you warning saying that you're having movement that's outside of the machine boundary, just because the work corner system is wrong. So usually just set the work offset first and then load the code. And then in that case, if it gives you any warning, then you know it's probably a real valid warning. Sometimes it might be scary to like click cycle start because you're not sure if your code is correct. But then there's many ways that you can kind of get a rough check. For example, in this screen, there's the Z, Y, and X. It shows you the coordinate system, and then here it shows you the tool. So if I move the tool around, so if I move, for example, the X-axis, I move it around, the tool will actually move on this screen. So and then you can just move it around and see if it looks correct. So I know the coordinate system is shown here, and then I know that the program right now thinks that the tool is slightly towards X positive, and then about like perhaps maybe around 12, maybe around a centimeter above the workpiece, roughly, just based on the tool diameter, because the tool diameter is 4mm. That you have set here in tool 1, the diameter is 4, and so you can see, so this is what the program thinks, and then you look at the actual thing, and then I think so this looks pretty close to what that screen just showed me. It's slightly towards the X positive position, and then it is around 1 centimeter above the workpiece. So this gives me confidence that I have set my work offsets correctly. Before I start running the program, I like to take the tool setter out, because this tool setter, it's loose here, and then it's gonna move around, and there are screws to secure it if you want to, but I like to keep it mobile, so I'm just gonna leave it outside of the machine, roughly like this. And I usually just leave the cable on. Now we're pretty much ready to run the program. So there are a few things that you can do to kind of be slow and make sure nothing crashes. So single block, if you press single block, then every time you press cycle start, it's just gonna run a single line. So when you're not sure about your program, it's good to leave single block on, just run the code line by line, and make sure the movement is what you expect. And if something is wrong, it doesn't go wrong really badly. And then the other button is feed hold. Basically, anytime when the machine is running, if you press feed hold, then it's just gonna stop. It's just gonna stop there with the spindle, keep on spinning. So when the program is running and you're scared, just keep the mouse at feed hold. And then if something goes wrong, just press it, and then the machine will stop. The other thing is that you can override feed. So here I can change the feed rate to, for example, 20%, that means that the tool will actually move only 20% of the speed of the what you program it to go, and then you can just go slowly at the start to make sure everything looks good, and then when you feel confident, you can change it back to 100% and run the code normally. So I'm about to run the program, and to be ultra conservative, I'll put on single block, and then I will override the feed to about 20%, just so that everything will run really slowly and in control, and I can see if everything is what I expect. And then I will also override the enclosure switch just for filming purposes. And then, but usually you have to close the enclosure in order for it to run. But right now I'm wearing, so I don't recommend this, but for filming I'll do this. So I'll override the switch, and with safety goggles on, and with single block on and this feed override, I will start clicking cycle start. So cycle start. So now it's running the first line, and then I'll keep pressing, running the next line. The yellow highlights which line is currently running. And so now I just ran the code G30, which tells us, I'm not sure, I think it tells it to go to the G30 position, and now it will start the first operation. So pressing. So now I have started the spindle, and I'm just gonna keep pressing cycle start with my mouse. And then so at all of this time, I'm looking at the tool, and I'm looking at the screen here and see if everything looks correct. So right now I can see that the tool is already really close to the Toolpath, and that looks about correct on the machine. So now keep pressing cycle start. Now just slowly moving. So now I feel okay confident, so I'm gonna undo single block and then press cycle start. And now the machine is really slowly starting the ramping operation to start cutting into the material. And I'm gonna increase the speed a bit. So now I'll focus on the cutting itself. So now all the operation with the first tool is complete. And if we look at the controller screen, we can see that is warning us to change tool 2 in the spindle and then press cycle start. And then, but So far I haven't found a way to actually change it while the cycle is still running. So right now, if I try to use the shuttle, I won't be able to move the spindle. So the method I found is that first you remember which line of code that you're running. So it is we stop at 4103. So remember that or write that down somewhere. And then now you press stop. So you actually stopping the entire program. Next I'm gonna actually change. So now that I've stopped the program, then I can actually move the spindle around, and then I'm gonna change the tool to our second tool, which is a ball end mill. So now we're using the 39166 tool, which is a 4mm diameter ball end mill. So now that I have switched to the ball end mill, I cannot just rerun the program at the line we stopped, because right now we haven't set the machine doesn't know how long this tool is right now, so we have to set the tool length again. So first thing I have to change, I know that in Fusion 360 I defined this tool to be number 2. So I have to do that first here. So change it to here. 2. And then enter. And then now go to your offset page, and this I can change. Let me get better light. So I can change this tool. I know it's a 4mm diameter one, so I can change this to 4. It doesn't actually matter that much, but for the visualization on the screen, it will be better. So change this to 4. And then tool length I don't know yet. First I want to move the tool roughly close to where the tool setter is. So the reason why I like to manually move the tool somewhere close to the tool setter first, somewhere like close to here first, instead of just pressing the move and set tool length, is because oftentimes these clamps are actually higher than the tool tip. So if we look at it from the side, you can actually see that the tool tip, even though I already pretty much moved it all the way up, it can still hit the clamp. So right now, if you just press move and set tool length, it's possible that it could go from somewhere and just move as a straight line, and then hit one of these high points, and then break your tool. So move it somewhere close to the tool setter first. Okay, now that it's close, we have to put the tool setter back onto its stand. But you can see that there are a lot of wood chips here. So if we put this on right now, it's gonna affect the height of the tool setter, and it's gonna affect basically the measurement of the tool length. So we have to clean out this chip either with a vacuum or whatever. I'm gonna use a vacuum. Make sure you make this bottom clean too, because if there's another, again, a wood chip here, it's gonna affect your reading. So just clean off any dust or anything. Put it on there. Yeah, and I'm gonna move the tool higher up, and let me actually make sure that it is high enough. Okay, so now the tool setter, the ETS is on, and the tool is pretty much close. So I know that when it moves to the ETS position, it's not gonna hit something here. So now, again, verify that you're at 2.2. You're at 2.2, and let me just deselect this. Just press enter. Okay, so press 2.2 again, and then now click move and click this move and set tool length, and verify that you're at 2.2, and then I press. So now the machine has just updated the length of 2.2. And then we can go back. We're almost ready to go back to running the program. So I'm moving the tool back to somewhere close to where I'm doing my work, because if I start the program, like, again, it might run over some of these stuff, like especially with this tool that has a relatively very long, that's relatively long. Just be safe, and then move it closer to your work, so that when it moves, it won't hit one of these clamps. I also like to do kind of like a sanity check, basically checking whether you have set your tool length correctly. So we know that this surface in our work corner system, like this surface is the 0 height. So I'm gonna move the tool somewhere close to the height of the stock, and then just check from the program whether the tool is at near the 0 position. So I'm gonna move the tool down. Such that it's almost touching the 0 height, and I'm gonna go to my program and see if that looks correct. So here is my tool, and I can see that, and then my Z height, Z0, is right here at where the bottom of the blue line, and that seemed to look correct to me. Okay. And so now, and then I have to go back to my line just now. So I know the line just now is roughly 4103. So I go back to 4103, and then right click, and then usually you can just say start at line 4103 with no preparation. It's like these stuff, it will add some extra toolpath to go in, but I know this is between two operations, so it's safe for me to start with no preparation. So now this is highlighted green, showing that if I press cycle start now, it's going to start from this line. So I'll move the tool back up a bit first. Move it roughly to the working area, and then again I can do single block, and then override the feed to be slower. Just make sure everything is running as expected at the start first. So now I'll focus, and then press cycle start. So cycle start. Oh. So it just gave me a warning saying that linear move on line 4106 will exceed z-axis position by that amount. So I will investigate. So I found out why. So if we look at so the warning it gave us just now is for line 4106. If we look at 4106, then they say G0 Z15. That's basically telling the machine to go to the Z15 position. But right now, so I've already stopped the program, and then if I move the Z height, so right now I'm moving down, and then if I move up, and I move up all the way up, so right now it's at the highest position the machine can go, at the limit. You can see that the Z height is only 11.389. So basically it's not able to complete this line Z15 because it has hit the machine's physical limit. So one way to sometimes to solve this is that you can adjust this tool, like maybe you have put it in not deep in, if you put it in relatively shallow, then the tool is gonna stick out more. That means if the tool sticks out more, that means the machine has to move higher up to reach that line 4106, that Z15 height. So one possible solution is that I just loosen the nut, move the tool, push it all the way up, and then I have to reset the tool length because you have moved your tool. So that's one solution, but I know this won't work because I know that I've already installed the tool pretty much all the way in. So what I have to do is to adjust in Fusion 360, adjust the program. Like there's some heights that you define, like in terms of like how high it goes when it's just moving around. And so I know the machine is physically capable of doing this operation because right now the tool is already higher than the workpiece. So I know this is it's not like my work is over the limit of the machine. So I just have to adjust, go to Fusion 360 and adjust the code a bit, and then post the code again, and then rerun it. So I'll go to Fusion and fix that. So if we look at the Toolpath, if I highlight them all, some of these yellow lead in and lead out is probably what's causing the trouble, because these are really relatively quite high and causing the machine Z limit to be reached. And so we can actually go in and fix them. So let's look at the first operation first. So look at operation, and it's going to be at the heights tab. And so yeah, so here's the problem. You can see so each of these heights, there is a there's a value to it, and this is relative to the work corner system that you have set. So in this case is this corner system, and you can see that for the clearance it is at 15 millimeter, and we can see that just now we have see that our limit was actually 11.389. So this is what's causing trouble. So I can actually just drag this I can just drag this down. So I'll drag it until it is less than 11.389. So that's okay. And then the same thing for this. Clearance height. So this one's 15 also. So drag it down. I'll just drag it around. This. You can also set the value here, but just like, because it's not the exact value, doesn't really matter that much. You just have to be lower than what your machine limit is. And you can actually there are probably ways you can set that height all at once by doing select them all, right click, and compare and edit, and then just find the correct parameter and then change it. But because we're only having four operation, I'm just gonna do this one by one. Height. So again, this clearance is at 15. Drag it to, that'll be okay. Lastly, edit height. And okay. So yeah, so I've dragged the highest height, the clearance height of all four operation down. So now, oh, actually, I didn't have to do the first two because the first two is 2-1, which I've already done. So actually, I should have just dragged the second two operation, but that's okay. So now we have to repost the this two operation, and so just now when we post, we click setup and click post. But because we only want this two operation, we can just select this one. So select first one, hold control, and then select the second one, and then click post. Yeah, I'll call it droplet height fixed, and then I'm gonna save it to the USB. Select, and everything else will be the same. And so the post is the PathPilot Tormach post. It says post, and then save. And then so Visual Studio Code is gonna show up, and so we don't have to look at it, we can. So you can see this time it's only in the bracket there's only 2-2, which is what we expect, because we're only posting the second two operations. So now I can close this, and then I can eject the USB and then go back to the machine. So I have my USB with the new fixed code, and then I'm gonna plug it in. So I have the USB with the fixed G code plugged into the controller, and now I will go back to the Files tab, and then go to Tormach, and then find the new G code, and then again I'm gonna copy it over, find it on the left side, and then load G code again. Okay, so now it's only posting the code of the second two operation that we designed using the ball nose Endmill. So, and I don't have to set the tool lengths again, because because I haven't changed the work coordinate system. So the work coordinate system is still at the Z height, the Z0 is still here, and then the X and Y is still at the center there. And so pretty much I can just directly run the program now. And I would take out the ETS. Okay, so, and then again I would keep it as single block, and then the feed override it to 20%, and so I can press cycle start. So I'll stop cycle start, stop single block because it looks okay, and then just cycle start. So now it has started that spiral toolpath down the cone. And now I'll change the feed rate override back to 100%. So that's it, we're done. Now we can take off the clamp. Oh, wrong side. So yeah, the surface looks not bad. Could be better. There's definitely some roughness here, but from some angle it looks good. But yeah, basically this is the whole workflow of the xsTECH. So if we take a closer look under the sunlight, you can see the surface, some parts are good and then some parts are just not good, but I think with some tweaking of the settings, this is probably fixable. Maybe like use a shorter length tool. The ball end mill was quite long, which makes it less rigid, and maybe going slower or faster, not sure. But once you're able to run the machine, then the rest becomes more approachable.